Good morning, everyone. Today we have a new lesson about forces. In this lesson, we're gonna talk about air resistance. The objective is understand that air resistance and water resistance are forces that reduce the speed at which objects move. Today, we will talk about air resistance, and in the next lesson, we will talk about water resistance. You have learned that gravity pulls objects toward the center of the earth, right? But do you think all objects are pulled as fast as each other? These two poles are the same size. These two balls, wait. These two balls, this one and this one, have the same size, but one has much greater mass. This one has a much greater mass. Do you think they will hit the ground at the same time when dropped from a height? If we have two balls and they have the same size, this one and this one have the same size, and but one has a much greater mass. Do you think they will hit the ground at the same time when dropped from high? Okay, you have 1 minute to think about this question. And don't forget to write the answer in your notebook. Okay, time's up. You will know the answer of this question at the end of the lesson. Galileo Galilei was an Italian scientist and mathematician who wondered about this. In 1590, he decided to carry out an investigation to find the answer of this question. He climbed at the top of the Leaning Tower of Pisa with two balls of similar shape and size but with different masses. So um, he brings or brought two balls have the same shape and size but with different masses. He dropped both of the balls from the top of the tower at the same time. Both balls hit the ground at the same time. When he dropped the balls from the same time, from the same height, they hit the ground at the same time. Galileo's experiment proved that all objects fall at the same rate, so no matter what their mass is. But this can seem hard to believe. Think about a feather and a hammer. If you drop both objects at the same time, would they hit the ground at the same time? You have 1 minute to think about this question. If you have um, feather and a hammer, if you drop both objects at the same time, will they hit the ground at the same time? Okay, time's up. What do you think happened with astronauts stood on the moon and dropped these two items at the same time? Okay, the answer, the feather and the hammer hit the surface of the moon at the same time. This, this proves that Galileo's findings are correct, that both objects will hit the ground at the same time. Can you think why the two objects might fall at the same speed on the moon, but the feather falls so much more slowly on the earth? So in the moon, the feather and hammer they hit the ground at the same time, but in the ground or on the earth, the feather mm, falls so much more slowly. So, can you think why the two objects might fall at the same speed on the moon, but feather falls so much more slowly on the earth? What is different about the moon and the earth that could cause this happen? The difference is there is no air on the moon. Air pushes against any object moving through it. This is known as air resistance. On Earth, air resistance acts on both objects. The feather has a large surface area in comparison to its mass. The hammer has a small surface area in comparison to its mass. Air resistance therefore has a greater upwards force on the feather. Since there is no air on the moon, there is no air resistance to push against the feather, so the two objects fall at the same speed. Okay, let's take another example. If you have two balls, okay, or if you have two pieces of paper and they have the same mass, but one crumbled into a ball, like in this picture, and the second one as a flat sheet, which will hit the ground first if it dropped from the same high, and wide. Which will hit the ground first? The crumbled paper or the flat paper? Okay, you have 1 minute to think about this question. Which one will hit the ground first? And don't forget to write the answer in your notebook. Which will hit the ground first if it dropped from the same height, and why? Okay, the crumbled paper will hit the ground first because it has low surface area, but a flat sheet has large surface area. Large surface area. This is called surface area. It has a large surface area. So more resistance will push it up, or more resistance will act on it. So crumbled paper will hit the ground first. Okay, a resistance can be a useful force, but it can also be unhelpful in certain situations. Look at the two diagrams below. Which one shows a useful effect of a resistance and which one shows unhelpful effect of a resistance? Which one is useful and which one shows unhelpful? Think about this question. Which one? Okay, let me tell you the answer. Okay, the answer is a resistance pushes up on the parachute, opposing the force of gravity and making the parachute and the person fall more slowly. This is a useful effect. But a resistance pushes the cyclist back, opposing the cyclist force. So this making the bicycle travel more slowly. This is an unhelpful effect. So the resistance um, helpful, but in bicycle unhelpful effect. The Super Skydiving Company are redesigning the parachute that they use to allow people perform sky dives from aeroplane. They want to make sure that the parachute they use allows their customers to fall from the aeroplane as slowly and safely as possible. The perfect parachute will be the one that makes a person fall the slowest. It will cause a resistance to push it up with the biggest force. This is your homework. In the two pictures below, the arrows represent forces acting. Write the name of the forces in the boxes. For example, this one, okay, this represent or this represents the gravity. So write in this box gravity, and this represent a resistance. So write in this box a resistance. Okay, I'm gonna send it on Google Classroom. Thank you.